All right, most anticipated demo of, of the year right here. All right, so let's get started. So the context for this is Flurry is a really cool graph database, semantic, uh, backed by immutable ledger, has a bunch of query languages. So I took some notes on it before in chat, on Twitter, on Discord, and they gave us a demo a week ago. Brian and Trey, and that was a really cool technology. We wanted to learn more. Thought it'd be great if we did the second demo with the community. And Brian and Trey were super nice with the time and said they would be open to that. Flurry, Mate said he wanted to moderate this. He's been a big fan of Flurry for a long time. He put it on my map originally, and so I'll let Mate moderate most of this. So I won't say too much more after this, hopefully. But yeah, if you have questions in the chat, post them in the chat. If you have questions, you could probably just say something too during the conversation. But really excited for this whole thing, and I guess I'll hand it off to Mate at this point.
Cool. Yeah, thanks, Jeff. I think you pretty much covered it. Flurry is a semantic and memory graph database backed by immutable ledger. It's built with Clojure, it's open source, and this is part 2 of the demo. And I'm gonna go ahead and post the first part, the link to the one that you did with Brian and Trey, into the meeting chat. And then as for what's actually gonna be covered, I'll flip it over to Brian to talk about that. But just before, as Jeff mentioned, if everyone can just kind of keep on mute and post any questions that you have into the meeting chat, and upvote each other's questions if you want to make sure one of them gets answered. But it's mostly casual, so if there is something you want to jump in with, go ahead. Just want to kind of keep things clean. So yeah, I'll go ahead and pass it over to Brian if you want to give us a little overview of what this demo will be about.
Great. Sounds good. Just confirm you can still hear me.
Yep.
Okay, good.
Yeah, confirming that someone is recording, or more than one person.
I am recording. I don't know if anyone else is.
All right. Great.
Go.
Well, I still apologize for the video. I've tried a bunch of settings here, but it looks like I can at least share my screen, which will be the important part today. The goal here is to just give a good introduction to some of Flurry's capabilities. One of the things that we were able to do in the prior meeting that Jeff referenced is just do some simple transactions and some simple queries. The goal here is to extend it and demonstrate a few of the other capabilities. It still won't be completely in depth. I think there's a lot there. Maybe your questions will allow us to dive a little bit deeper. I don't know all the areas that will be of interest to this group, if any areas, which is fine too. So I'm going to try and cover a lot of things with a broad brush. I'm going to focus much more in Clojure world, because I believe most everyone here is, Clojure. Lots of times when our focus with Flurry, even though we're obviously huge Clojure fans because we've developed it in Clojure, our focus was not primarily Clojure developers. It was more just a back-end data platform, targeting probably a lot more even JavaScript than Clojure. And so yeah, I mean that's kind of a brief background. I have been in enterprise software for over 20 years now, built several companies in this, and Flurry is really a passion for me. I think I've worked on it now for 5 years, using all my own money for most of that 5 years to focus on getting a product that I was really happy with that could do the things I thought a data platform would need to do. I'll start out by saying where Flurry's focus is. It's in what we call a data-centric applications. So that's opposed to application-centric, which means, you're trying to build an app and the data is kind of a artifact of your app, typically designed and developed by developers. In the case of Flurry, we really want data to be the first-class citizen. Doesn't have to be. You can still use it like a normal database if you want to. But it really shines in what we call a many-to-many environment, meaning there's many transactors, many parties transacting data, and many parties consuming data. And this is vastly different than a traditional database, which lives typically in a one-to-one environment, which is the app server in front of it is the only thing that can transact to it, and the app server in front of it is the only thing that can query it. And if you want to expose any of the data outside of that realm, you're building APIs and you're doing some of these other things. So Flurry can actually, in fact, I'll demonstrate it here today, can be run with quite literally no app server. It can embed data permissions directly into the data tier, expose multiple query interfaces. No app server required. Now, obviously, a typical application is going to have some sort of app server needs, whether that's sending users registration emails or things like that. Flurry's not going to do that sort of thing. But as it relates to data, querying data, getting access to data, getting data to front-end web browsers, etc., there really is no app server required. So with that, I know we don't have a ton of time, so I will jump in and just really try and do the basics here. Just let me know if you have any questions that do come up. I know Matej said to use the chat, but also happy to get interrupted.
Cool, and just want to make sure, are you, okay, there we go. You're sharing the screen now.
All right. Can everyone see IntelliJ?
Yep.
Okay, perfect. All right, I'm gonna actually try and move Discord over here. So it's my first time presenting in Discord, so. All right. So again, the focus here is very closure. So with that in mind, I'm gonna be using IntelliJ here to do a lot of what we're building with Clojure. I'm gonna quickly do a recap of what we already showed Jeff in the last meeting. So I know some of you might have seen that on the video, some of you might not have. I won't spend much time there in case you have seen it, but it'll either be new or a refresher. So this is just a standard Clojure project. If you look at the deps.eden, I actually have a local development one that I'm using, but you can just use, the Clojure's version of Flurry, the library. Flurry in this case is running as a server. The server is actually running at this port. I guess this is one important thing to point out is that Flurry by its nature, the backend or the ledger backplane can be clustered and has fault tolerance built directly into it. So I might actually be running 3 ledger servers and they're all participating in Raft consensus. And, they might all be at different IP addresses, and that would be a perfectly fine thing to do. If a server goes down, you have 0 downtime. It'll automatically rebalance. All the data is copied across all the backplane. So you have a full redundant system. And if you're familiar or if you've used like HashiCorp's console or tools like that, then you're familiar with Raft. But generally, you want to run 3 servers or 5 servers, depending on the amount of redundancy you want. A nice thing about this is that Raft, we actually have it, right here, in case anyone's interested, we actually have the complete Raft library that we have built, which sits as a library. So if any of you have had to run things like Zookeeper to maintain consensus across apps or anything like that, I would encourage you to try this Raft library. You can literally embed the equivalent of Zookeeper right into your application if you want. That's what Flurry's using kind of under the hood in the consensus. So I already created the connection here in the REPL, but what we'll do is we're going to create a new ledger or a new database, if you will. And I'm going to call this Athens test 3. So here I just did a def. I haven't created it yet, but I'll go ahead and use the flurry.db.api namespace, which has all the kind of Clojure APIs in it. And I'll go ahead and create that ledger using the connection in that name. And once again, the servers reach consensus, meaning at least two of them, in this case, if there were three, I'm actually just running one, two of them would have to acknowledge and durably store all the information related to the new ledger before you ever got the response, but you will get the response once consensus has been achieved. And so the first thing we're going to do is create a schema. I think you're all pretty familiar with this. I actually put the schema down here, but I'll walk through it real quick. So what we're going to do is we're basically going to create a couple buckets. We call these collections to store things in. This is, I guess, inspired by Athens. It's certainly not your exact schema that you're using right now, but we're going to create a bucket called block, not to be confused with Flurry blocks, which we'll also talk about. But we're also going to create this bucket called org. And there's already a couple sort of core schema elements in Flurry when you just create it. But then these are going to be all of what we call predicate and not just us. So we very much follow the RDF standard. So I'm sure a lot of you are probably familiar with RDF, or if you're not, certainly you've probably heard of different triple stores. And triple stores in our RDF database, so semantic graph database. And in this case, we're going to be giving these predicates, these columns, if you will, names. Like, for example, this one's a ref, and this is going to point from a user record to the blocks that they've authored. So it's a ref, multi-true, meaning multi-cardinality. And we've got this restrict collection in here, which is going to make sure that anything you point this reference into is also of type block. That becomes important. It's not mandatory, but if you're going to use GraphQL, for example, Flurry natively exposes a GraphQL interface. If you're going to use GraphQL, like GraphQL is strictly type. So anytime there's a reference, for example, in GraphQL, it has to be one distinct type that reference is. But it would be optional if you didn't want something like GraphQL. So it depends how strongly typed you want it. In here, we're going to create, an email and some other block string, which I think is what you currently use, etc. So sure we have this, and we'll go ahead and transact that. The schema, and once we have the schema, we can start putting some data in. So a few of these things I'm going to do are kind of basics, and I think it's important if you try and design a better mousetrap that you make sure it can catch mice. I don't know if you've heard that adage. While Flurry can do some interesting things, it can run decentralized, it can do a lot of federation, it's got blockchain componentry in it. If you can't run it like a normal database, then, we haven't hit the bar. So what I'm showing you right now is forget about all of that stuff. It's kind of sitting in the background, waiting for you to use it if you want it. You don't have to use it. If you want to run this just like a back-end typical database with an app in front of it, you really don't even need to know about any of those things if you don't want. So here's the result of our schema transaction. And what we're going to see is what we call flakes here. Flakes are basically, an extension of RDF data, an extension of triples. I think a lot of you are familiar with some of the, closure technologies out there that are based on data log, et cetera. So you'll be kind of familiar with some of the same concept. But basically, we're writing out all of the deltas, all of the changes. Importantly here, everything is cryptographically signed. Everything can be provable, but I didn't set any of that up, and that's because it's our opinion. If you don't care about that, we end up generating basically a default private key that's used to sign transactions. And if you care about it later, you can sort of open this capability up. But if you don't care about it, it's just there, it's in the background. But all of these blocks are going to have a hash. They're going to have signatures around the original transaction, which allows you to prove identity. So there's all this cryptographic proof that exists if you ever did want to go back and get it. Again, it stays out of your way if you don't care about it. Another thing that we output in Flurry, and this is important because it is designed to be a many-to-many environment, like I said, which means you don't always have control if there's many different entities updating data on usage. We have this concept we call fuel. And everything you do in Flurry. Every query reports fuel, every transaction reports fuel, and fuel is the amount of work that the computer had to do to fulfill the query. And we'll do, some real high level smart function stuff here. But for example, as you're running code inside the database, it's consuming fuel. The operations are consuming fuel. As it's touching data, it's consuming fuel. So in this case, this transaction consumed, a little over 3,000 fuel, took about 10 milliseconds for a brand new ledger. So, this is running on the JVM and it's not warmed up at this point. Okay, we got our schema in there. So let's just go ahead and create some users. Feel free to jump in if there's any questions. Okay. So here's a user transaction, and I'll just explain a little bit what's here. So we use this underscore ID as a unique identifier. Ultimately, the underscore ID is going to point to these long integers, which are going to be permanent identifiers within the ledger. In this case, it's telling us what sort of collection or class to put this data in. So we're going to say, put this in the user collection. And here's just some information. So Trey's email, an ID stuck on it. And importantly, Flurry has this ability to have and manage multiple identities, multiple auth records for an individual user. In fact, every auth record can even have different permissions. And this can even start allowing things like, if I wanted LinkedIn to be able to get access about me, I could actually set up an auth record because now LinkedIn is authenticating as me, but I can set up specific permissions that says, LinkedIn can only see these two fields. Or if I log in, I have a different auth record that I'm using, and I might have my full capability and permission. You can also do things like key rotation really easily if you are using private keys when you have multiple auth records. Every time you transact, for example, if you wanted to, you could delete your old auth record and put a new auth record in if you have the permission to modify your auth record. And all these permissions, it's up to you to set up how you want. Again, we'll cover those here in a minute. But so here's a few users. So we'll go ahead and do that. And we're actually going to put in a few cryptographic keys here. So this ID is really a derivative, and I think I have them here. Yeah. So Trey, here's a public key, here's a private key, and here's the auth. So the auth is the piece that we're putting in here. And using this private key now, I can actually interact with Flurry by cryptographically signing queries, cryptographically signing transactions, and I need no identity server in between. So Flurry will have the ability to figure out that anything signed with this private key must have come with this auth. And now, because we transacted it here, we know that this auth is associated with Trey. So we have identity based on the cryptographic signatures. Again, only if you want it. We're kind of running Flurry here in root mode or like you'd run a typical database. But we'll show a little bit of this as we get on. So we'll go ahead and put it in here now. So I already did that. So let's transact for users. All right. So we have users transacted in it. Good time to issue a couple simple queries. So databases are immutable. So in this case, we're going to just create a database. We're going to use the connection in the ledger to create one. If we don't specify time, it's going to use the latest database that's available. And so I thought we would start out because everything in Flurry is really at a core based on the W3C standards. Sparkle is the query language of W3C semantic graph. So I figured we'd start out with a Sparkle query. So this will probably look very, very familiar to you. With Sparkle, any variables, you always prepend with a question mark. You specify sort of the predicates, or probably in your language, entities. And then you can also bind variables really anywhere in here. And then you're going to produce these variables in your select statement. And of course, you can do aggregates, you can do all kinds of functions in here. This is a very simple query. It's saying basically find me all the subjects that have a user email, bind it to this variable, and that's what I want to select out. And we will see based on those three users that we put in, here's our response right here. So we've got Jeff, Brian, and Trey in there. Now, we have a way of querying Flurry that takes Sparkle and it puts it in a data structure. So this is the identical query as the Sparkle query. But at this point, we're actually using a data structure to represent it. And I think a lot of you are familiar, and I won't go into why we see value in representing queries as data structures. Importantly, this can be JSON. In this case, I'm representing it in Eden, but identical query should have the identical results, and there you go. And then I thought, just because I know you're using DataScript, you will see that the difference between the Flurry query here and the difference between the DataScript query here is there's virtually no difference, and that is because this is entirely based on Sparkle. So Sparkle was kind of the origin of I think much of this thoughts, the thoughts that went into this. So all these queries are sort of the same thing. We do allow you, if you want to crawl the graph, you can certainly do that. So we're going to use this same query that we just did here. Instead of binding that email address, which we don't really care about, we're just going to have a blank sort of node here. So this is going to find all the entities or all the subjects using RDF vocabulary that have a user email. And here, because we wrap these in a map form, we're just going to say bind that subject and then crawl the graph out. And I do want to point out that you can use keywords here. So we're using a lot of strings, but you can use keywords. Here's a good example of using keywords. So we're going to crawl all the users. We're going to pull their email, and then we're going to crawl all of their auth records, and we're going to pull out their auth record ID. And of course, we get this nice graph that returns. So again, you're probably pretty familiar with those concepts. The whole point of all that is, again, kind of just showing that all of the basics, all that core are there with Flurry and ready to use if you want to. Okay, any questions?
I've been a couple of questions in the chat, Brian. I don't know if you want to go back to some of those. You want to keep doing the demo and circle back to them at the end?
Maybe Matei, I know you were going to moderate it, so you tell me. I'm looking to where the chat is. Is this in a specific room?
So it should be in the meeting chat. And I actually, I just realized I tried to mute everything for the recording, so I wasn't seeing the questions that were being posted here. Trey, do you see any that stand out that you think should be tackled first?
Do you want to delve into a little bit more on the LinkedIn example you were using, Brian, for the author? A couple questions about a little bit more advanced authorization.
Yeah, I mean, the whole idea is that because, this is a data platform that can exist like on the public internet. It doesn't have to exist behind a secured web server. We call this, or an app server. We call this, Flurry has this ability, we say that data can defend itself. So you can only see things you have permission to, you can only transact things you have permission to, and we'll get into how to do that. But because we need this sense of identity then baked into the core platform, it really makes sense to offer a lot of flexibility in how we validate users. And so the idea that multiple auth records are there are simply that, a user might maintain multiple private keys. That's a fine thing to do. They might do key rotation. So they might have two different auth IDs to authenticate while they're in the middle of a key rotation. But every auth can be tied to certain permissions. And once we get into the smart functions and how we sort of link the smart functions to this, you'll see how that happens. But yeah, there's no real limit that, a user, in fact, you don't even need a user. In this case, we're using users, but technically all you need is auth records to define who can do things in the system.
And one other one was, go ahead.
Yeah, I have just a quick question. So I just want to get, I'm not that experienced. I'm just new to the idea of decentralization. I understand the logic of what you did and what you show, but I still don't get the grasp of the idea is that this mechanism does not need a specific server. Where does the database gonna live if we don't use a server and we want it to be reliable that everyone can access it?
Yeah, so Flurry, importantly, decentralization is one of those words that's very loaded. So it is important, I think, to define exactly what you mean. Flurry cannot be decentralized like Bitcoin, for example, can be decentralized. Bitcoin is a public blockchain. It has, for one, it's slow. It's never going to work fast as a database. But it's not what we designed the platform to do. So there's a number of concepts around decentralization that Flurry can do. One is that, as I mentioned when we were coming in here, that these ledger servers here, there can be multiple of them. They actually don't have to be run by a single entity. So multiple corporations, for example, could all be running them. We're doing a lot of work with Department of Education. In fact, in California, we're hopefully about to start a project where they have kind of three main divisions in California. There's Southern, Central, and Northern. And they're working on interconnecting all of the student records so they can guarantee the privacy, some of the things, that Flurry is able to do for them. But they want all of them to kind of balance each other out. So they just don't want Southern California to run all the servers. They want someone in sort of each of these areas to do that. So that's certainly an option, something you can do. Yep, go ahead.
When you have like multiple links or URL to the server, does that mean that each server will have like identical snapshot of the data?
That's right, because the Raft protocol that's running behind this is guaranteeing that the servers are arriving at consensus.
So if the so you don't just depend, like it is on the architecture of this technique or technology that you don't have to depend on a specific server. It is like by design, you can like spread it out.
Absolutely. And in fact, here, this query string, what it'll end up doing when you try and connect, if there's multiple servers, it'll actually try and connect to all of them. And whichever one responds first, it'll end up forming a connection to. But if that server ends up dropping, it'll jump to one of the other servers in the connection string.
And if someone else is doing some transaction with a different link, it is like those server will sync between each other.
Absolutely, yeah. Yeah, in fact, they won't respond that the transaction was successful until more than 50% of the servers have seen the transaction and durably stored it.
I get it. And that's what the essence of Ledge and the blockchain is coming, right?
Well, I mean, Raft is a pretty common protocol. So if you've used like HashiCorp console, for example, you can. So Raft is a private consensus protocol. Something like Bitcoin uses a public consensus protocol, which has a completely different trade-offs. But yeah, we're using a consensus protocol to make sure the servers are always in sync.
And consistent with each other, yeah.
And consistent with, yep.
Yeah, makes sense. Thank you very much.
All right. Cool. Well, I will, and I'll try and pick
to ask, I asked in the chat, like, how it's feeling like if we want to go into more code or more into like, just like demos of what's possible, like user journeys and examples of like what would LinkedIn look like, or like what would Athens look like, sharing TVs, or like sharing blocks and pages with one another. I'm not really sure what people want, but I do know that some people here are probably into the code and some people maybe less.
Okay.
Sure.
Well, let me, so good feedback, Jeff. So what I'll try and do is kind of balance it out a little bit. I will show some code, but I'll definitely explain why and how some of these things are there as we go through.
Yeah, thank you.
Okay. All right, so we have some transactions, and we have transacted some block data in there. I believe the last thing we did was we started to, or I don't know if I transacted. No, I didn't. Okay, so there, I just transacted all of this data right here, which is the block data for, the sample Athens kind of block data here. It's got a bunch of blocks and sub-blocks, children, et cetera, in it. So now we have some block data sitting in there. And of course, I can query that out as the graph, and just pointing out here that, time travel is fully there as well. If I wanted to issue that identical query, but instead of using the latest database, I'm using a database. In this case, I'm using a database 5 minutes ago, whatever that database is. I query, there's no data because there was no data 5 minutes ago. This, by the way, is the ISO 8601, standard for duration. So anything to the right of T is like seconds, minutes, hours. Anything to the left of T is days, months, years, etc. So here I'd say 1 minute ago, and we didn't have data in there 1 minute ago, but in about another 20 seconds, obviously it would be the latest version. You can also lock this into very specific moments in time. I can say I want to do this as of, block 4, and there the data was in there, but if I go back to block 3, it's not in there. So anyway, mutable databases, time travel, you can issue the query across them, things I think a lot of you are also familiar with. And of course, you can read all the block data as well. And like I said, that's always going to have all the cryptographic proofs if you ever did need to prove out any of the data. If you don't care about that, you don't have to worry about it. It's just kind of sitting there in the background. All right, so let's jump into smart functions. This is kind of where we were heading, I think, the last time I was talking to Jeff. So the idea is that data should be able to defend itself. And if you're able to expose data more directly onto consumers who need it, as opposed to them having to go through custom API development to get it, they can then start using very expressive query languages to just ask for what they want. Flurry supports GraphQL, like I mentioned. We support SQL. We don't support all of SQL, but if someone knows SQL and doesn't know Sparkle or these other things, that's fine too. They can still get some queries going. Of course, we support Sparkle. What I was showing you was what we call Flurry QL, which is really Sparkle in JSON, or in this case, in Eden. But let's create a smart function now that starts to lock down this data. So I'm just kind of, again, using this like a normal database. Flurry is configured right now with what we call Open API on, meaning that it will allow kind of a root access. If you turn that flag off, Flurry will not allow anything unless the query or transaction is cryptographically signed. So we're going to play a little bit with both of those here. But what I want to do is I want to create a smart function. And this smart function is going to say that you can only see your own blocks, right? So if these are my notes, I can only see my own notes. I can't see anyone else's notes. And this is actually the smart function that I want to put into the system. And I'm going to show how this is done. You write smart functions effectively in Clojure. You are going to have all your normal sort of Clojure functions available to you. So you can do quite a bit in this. We have a special out-of-the-box function we call relationship. And this is just because it's really common. And what we're doing here is we're basically bookending whether or not someone can see data by following the graph. So remember, every time anyone's interacting with Flurry, there's always an identity tied to it. So on this side, we're getting the identity. We know that identity is tied to a user. We know that the user is referenced from the block, from the notes, and then this would end up being basically the block, the subject ID. These are functions that actually have a hidden context that's passed in as they're headed in. That's as they're being executed. That's why you don't see any arguments on this subject ID or auth ID. It's because this context of the transaction is sort of injected into the function. But it's basically going to make sure this relationship exists. So, here's block user. So it's basically saying go from the auth to the user up to this block, and then can the user see this? So in order to put this in, I'm going to transact this into our function collection. So I'm just going to take this smart function code right here. I'm actually going to create a function out of it, but our function's now in Flurry, but it's not doing anything. Now we need to hook into how do we trigger this function to actually do something if we want. There's really two big things you can do with smart functions. One is you can do data validation, and we call these specs, not to be confused with Clojure spec. But they allow you to set up any type of, as complicated as you want, criteria for what must exist in data. For example, you could say, a new block can only be created if it references a user and that user has, 5 friends. That's something you could say if you wanted to and express as a smart function. The other thing you can use smart functions for is to enforce permissions. So that first example might be just a generic, data always has to look like this. This example is data is going to be tied to identities. So our smart function's in there, and how do we tie this now to an identity? And that's going to be this next piece. So we are going to create a what we call a role, and a role is really just a grouping of rules. But it's this rule that ties the smart function that we created into the logic. And you'll see here this rule we're going to create. We're going to say here, just in a doc string, that the user can only read and write their own blocks, meaning their own notes. And we're going to reference this function that we just created, that smart function. And we're going to say this is going to apply both for queries and transactions. So this can be 2 distinct operations. For example, I might have permission to transact something, but I can't look at it. Or I might be able to look at something, but I can't transact it. In this case, we're saying, the user, this smart function can enforce that. How we trigger this to only look at blocks as opposed to any other data in Flurry is right here. We say this is only going to apply to blocks, and we're actually going to set this up as a default. So individual predicates or entities can even have their own rules. So you can get very, very granular in this. So we'll go ahead and set up that smart function. And now the only thing left is to tie the identity to this role. So we call this role standard user. This is presumably what we would get of every standard user who signs up to the service, this role. So we never have to write any other permissions besides this one. And in this case, I'm just going to attach it to Trey. So I'm going to update Trey's auth record. And again, I had his auth ID in that previous namespace over here. So here, auth Trey, here's his auth ID. So that's a unique identifier. You can use 2 tuples to uniquely identify anything in Flurry. So for this ID, we're saying for the auth ID, get that auth value, and we're going to set this role up, this standard user role that we just created here. So now Trey has this associated with him. And what we can do is we can create a database, call it TreyDB, which creates a database just like we did before, but we're actually saying this database has an auth attached to it, and it's that auth, the Trey auth that we just created. Now again, Flurry will automatically attach auth to it by decoding cryptographic signatures if it's open. This is kind of assuming that you're using Flurry from a front-end service. And if I use Trey's database and I issue that query, that's fine. I can see everything. That's because all these blocks were actually written by Trey. But I'm going to also here get a bplatz database where I'm going to actually attach the auth to bplatz, and I'm going to issue that identical query, and I see nothing. So what happened here is now Trey has basically a virtualized database that only has data in it that he can see, and he can issue any query he wants. Brian has his own virtualized database. It only has the data in it that Brian can see, and he can issue any query he wants. And when I mentioned before, you don't even need an app server, this is partially why, because usually we're using the app server to enforce identity or permissions. And again, you can still do that. There's nothing preventing you from doing that. It's a perfectly fine way to use Flurry. A lot of people use Flurry like that, but you don't have to. You can actually open it up, and this is going to open up anybody to write apps or anything around the data that's being stored, but always guaranteeing the permissions in place.
So Brian, just to clarify, so you have the core ledger, which is where you transacted all the data in the first place, and then you created 2 essentially query servers that are TreyDB and Brian Platts DB, each of which are attached to certain roles. And based on those roles, you kind of have a virtualized database for each that can either access the set of transactions in the core ledger or not, right?
That's correct. Yeah. So whatever sort of smart functions are tied to them is going to govern what data they can see. And again, the powerful thing here is that you can use the relationships in the graph. So, there's nothing preventing you from, for example, introducing a new predicate called friends. And you could say, well, if I'm linked to a friend, it means I can see their notes as well. And then the next time you say select star from notes or blocks here, you're going to see not only your notes, you're going to see your friend's notes because that relationship is there. And as soon as that person unfriends you, they're going to disappear.
Awesome.
So you're using relationships in the data to do this. But no one knows what data is there that they can't see. So it's very important to Flurry that we never even allow a hint of data that might exist that the user doesn't have permission to, even in its evaluation. So I just want to show another sort of extension. So we kind of showed virtualized databases with permissions, etc. That can be a whole topic in itself. I'm just trying to touch on some of these concepts here at a real high level. So let's do one where let's create a couple extra schema elements. So we'll create a new collection called artists, like a painter, for example. And say we're creating notes, and that note we want to link to the artist because it's talking about an artist, or that note is doing something else. So we'll create a new reference off of a block called artists, and we'll allow you to store, in this case, an artist string. It's just an arbitrary example. So what I'm going to do is I'm going to create a new block. Here's my block UID. Here's my block string, hello. And in this case, I'm going to reference, this note talks about Gustav Klimt, which is, a fairly famous painter. Probably I said his name wrong, but this note happens to talk about this entity. We don't know anything about it, but let's go ahead and transact it. Here's an example. So you can actually federate queries and use different data sources. In this case, we're going to use Wikidata because Wikidata also happens to be a triple store. There's triple stores coming all over the place that are housing data. And I would bet that Wikidata knows something about Gustav. So what I'm going to do now is if I'm rendering my block, for example, I can connect not only the data directly in my local database, but I can start dynamically connecting it with external data sources. So I'm going to issue the same type of query. I'm going to, pull out this particular block ID, which is the one we just created. Then I'm going to crawl the block to this block artist. I'm going to get out the artist name. And then I'm going to start to federate this. So there's another element that's introduced into the triple declaration in the query. $WD, we already know in Flurry $WD means Wikidata. So we already made that connection. But this could be another ledger. This could be a different Flurry server, et cetera, that you're combining it. And we're going to use Wikidata to pull in any information about our artists here that it might exist. And what we're going to try and do is, hey, I want to get a list of artwork. Of course, we didn't start the artwork here in Flurry. So we're connecting databases now to bring this information together. And there we just issued a query for a block that we stored here that connected to an entity that we just combined with Wikidata. And now we've pulled out from Wikidata all the artwork that Gustav has ever made, along with an IRI. So these ideas of federating data and connecting data across sources are really powerful. I did not get into this here, and we're not going to have time. Happy to do it again, but we're using kind of standard JSON here. We're using more of a data script like format, a kind of closed world format. You can also use JSON LD. And instead of identifying these underscore IDs and kind of this closed world notion of things, you can use a @ ID and use IRIs. IRIs to not only identify uniquely what you're talking about, but IRIs to even identify predicates, which means you can start having shared schemas. So like schema.org, of course, is a very popular shared schema. Google uses this. If you've developed web pages, you've probably embedded schema.org data right into your web pages. You could tag, instead of us having our proprietary, user username, we could use the schema.org vocabulary. Anyone using schema.org can now dynamically integrate with our data. They don't need to write integration scripts. They don't need to say, this is really that. It can automatically happen, which is a really cool concept.
I just have a quick question about the Wikidata, if possible.
Yeah.
So I know, I have been I'm a little bit aware of Wikidata and their logic. If you go back to the code here, where did you get the B178 B178, it does mean that you are looking to this entity in Wikidata. Where did you get that from?
Which part? Are you referring to this?
Yes, B17. Isn't that like a identification for
Yeah.
Wikidata?
Well,
So,
Wikidata is actually not a pleasant one to integrate with. So they very focused on being international. So they never
yeah.
use any language, any terms within it.
Mhm.
So if you wanted to find something about, Madonna, you can't find it by the name Madonna. You actually
Yeah,
have
yeah,
to
yeah.
find their internal tag. So this
Yeah,
happens to
yeah.
be the internal tag that Wikidata uses. But yeah, if we just took one of these URLs too, and just came here, right? So here's the painting that was referencing. We're on Wikidata. All this data is available to me.
Yeah, yeah.
Yeah.
And
But
that was
here-
no, I just was like, but you knew before had to use that tag, right? Oh,
I did because for Wikidata specifically. Now, again, if I was using like schema.org vocabulary, I wouldn't have to do that because schema.org, everyone's
yes,
going to
yeah,
use
yeah,
the
yeah,
full
yeah, yeah.
IRI.
Yeah. Got it.
Yeah. So if I wanted to define a person but use the schema.org vocabulary, I could use this vocabulary. Now, anyone else using this vocabulary, I can link and integrate my data with automatically.
How would real-time collaboration work with Flurry?
Real-time, actually, you know what? That's I think will allow me to show the last thing, Jeff. And this isn't going to 100% answer it, but I think it's a pretty cool thing, and we'll at least partially answer it. So what I'm going to do here is I'm going to use Create React App. And there's already a template out there, a Flurry template that just puts some of the Flurry plumbing directly in there. But I'm just going to create a front-end JavaScript app. No app server, again, no anything. And what we want to do is show how we can start streaming data events and real-time data quite easily. And I think collaboration is going to require at least a couple things. One is streaming data that multiple parties can understand. The other part, I think, is locking in time. Because how can you collaborate about data that's constantly changing? It's difficult to say, I know the same thing as you when the data might have changed between when we asked. But here I just created a React app template. Open this up in VS Code. And I'm just going to go into the app server here, and we just have, we're importing here actually the Flurry library. The entire Flurry database is in ClojureScript. We can compile it into JavaScript. In this case, we're actually going to run it as a web worker, so it's not even going to interfere with our main render thread. You can, of course, embed it in Node.js apps. In fact, we did a recent webinar where we did auto scaling on AWS, where we were just, hammering load against a Node.js app that had the entire database embedded inside of Node.js, and then used auto scaling. And of course, the example that I was just using, we're running literally the entire database inside of Clojure, inside of your own app. So you have this ability to embed the database as a library. In this case, we're doing it in JavaScript. So here we're going to point it at that same server. Let's make sure we point it at the right database here, which we're calling Athens test 3. Oops. And I'm going to run yarn start. All right, so here's Flurry running. It's connecting. It's actually the entire database, again, is running in a web worker. It's just using this out-of-the-box template. But let's say, we have this sample. You can just attach queries right to React components if you want. But we want to pull out blocks, and we want to pull out your UID, and I think, block string is the name. Go ahead and do that. Right, so here's the blocks that are currently in the system. they're sitting here in the browser, and the entire database is literally running in the browser right now. So one of the things, and I'll keep that there so we can see it, but let's just go back to here and let's create another new block. Blah, blah, just so we can see it. Hello, new transaction. Go ahead and transact this. So this is an entirely different process. Transact it, and you see all the data is instantly streamed to the front end UI and automatically re-renders in real time. So what's cool here is that if you want to use Flurry like this, you can actually embed it, no app server. You can when you connect in JavaScript, you can connect as an identity. Again, everyone's going to have a filtered database, and you have for free a permissioned real-time database that can automatically trigger re-renders in the UI. And you had to write, literally here, we wrote zero plumbing to do that. These concepts of streaming data, scaling data, embedding data into applications, they're really all there. The Flurry wrap or the React wrapper that we wrote in this particular case is literally a single index.js file. It's about 600 lines of code. But if you wanted to do this for Vue.js, if you wanted to do this for Angular, it's almost all the work here is Flurry. It's just sort of wrapping how you re-render components in these different front-end frameworks. But Flurry's actually triggering all of this. So I know we're about out of time, but I wanted to at least include that. So yeah, if someone was typing notes or anything like that, I would literally see the updates here in real time.
One last big kind of thing to cover, Brian, is do you want to talk about the licensure updates that we made? I know there's quite a few people that are interested in that.
Yeah, so, Flurry is licensed under Eclipse Public License 2, including the libraries. The ledger server, the backend server, is registered under AGPL. The backend server is not designed to be embedded inside of any app. So, only the database library is. So you would never embed the Flurry ledger server inside of an app. So the license there is, I think, less relevant. And if it is still relevant, anyone can download the version that we already compile. And then it has it's not even an open source license. It's just a Flurry free to use license at that point. But normally that ledger server, you would, throw in a Docker container, run it on Kubernetes, run it on EC2, run it however you want. But that wouldn't be what you would ever embed in code.
Yeah, because I know a lot of people had seen that we were AGPL a couple weeks ago. We just made the update. So I wanted to make sure that we brought that up on this demo.
I think there are specific questions in the chat on license.
Yeah, I feel like
Lauren did ask one. Oh, wait, is that just background noise, Jeff, or is someone asking a question?
It's background noise.
Oh, gotcha. I think Lauren was asking about the ledger server being able to run on employers' hardware, and so I don't know if you have any thoughts about that, or what that has to do with the commercial license, actually purchasing Flurry, how would that work?
The first part of that question, Matej, Flurry running on what?
She was saying on her employer's hardware, which I guess would be an enterprise that doesn't allow AGPL software.
Yeah, I mean, so you don't have to use the open source version of Flurry at all. You can just go. In fact, if you want, you can just go flurry.ee. There's a link on our homepage, but oops, get started. You can literally download it right here. It's already compiled. It's already in a jar file, and you're just using the Flurry, custom agreement terms. You're not even using the open source license. So the only time you're always using the open source license is if you're downloading it from GitHub, or you're compiling it directly from GitHub. That's where the open source license applies. Again, if you're running the ledger server, you're not embedding that with any or combining it with any other code. You could also just run our Docker version too. So
Or you
There's
can
no
use
reason I guess there's no reason you have to run AGPL code to run Flurry, is the short answer.
And we also have the on-demand version, so we have a version that we're serving on AWS that you can spin up a ledger on and then connect via HTTP calls. So it all runs on our servers. You're just building the client that's connecting to it. So I don't think that would invalidate any sort of employer contracts.
Yeah, and importantly, the ledger server does run independently from the query server. And so the ledger server, you have a lot of flexibility where and how you run that, but you can always run your query servers, close to your code in your AWS environment, et cetera. Well, in fact, we were just showing it here a second ago. We're running it inside of a web browser.
How much does it cost to run Flurry? You guys have pricing?
It's free. So Flurry itself is free. The reason you might want to pay Flurry is, for one, if you wanted services. For two, if you wanted a guaranteed service level agreement. So, if you wanted 2-hour or 4-hour minimum support for severity 1 issues, that sort of stuff, that's when a typical corporation. But we have a large number of startups that use Flurry, and I think we only have two or three of them that actually pay that. So most of them don't, and that's fine. I mean, that's part of what we want. We just want people to use the technology, help out, provide feedback. If you like it, tell your friends. If you don't like it, tell us.
So for Athens, what would the implementation look like? If Athens is using it, say we have some people that want to self-host us. Maybe they're more technical, they have to self-host their own data, and then there's also some users that it's not as important to them to self-host, but maybe they still want some sort of collaboration. Up until now, I was thinking more in the typical model of software, which is there's the self-hosted ones, they're kind of their own thing. Maybe the entire company uses it internally, so some people will use GitLab completely internally, it's all self-hosted. And then there's kind of the SaaS thing where it's we can just collaborate really easily with anyone, but it's all this centralized server. So that's the Notion. You just add me as a collaborator. I already have a Notion account. It's really easy to edit. What would kind of the collaboration model look like?
Yeah, I would probably, I don't know what your customers are asking you to do, but I would probably run a Athens, hosted version. Give people the option of running maybe a packaged version that can, have the data locally if they want, but you're kind of managing the backplane. You're managing sort of all the core ledger data and all the changes there. You could bundle it up with your offering if you wanted to allow people to run the whole thing in their own environment. If people want to, when we have people nowadays who are trying to run Flurry in their own environment, lots of times they want to run it on Kubernetes. So that might be another option, is you could just set up some Kubernetes scripts that allow people to kind of spin up the different services real easy that are required to do it. Importantly, so the data backplane is going to have to run as a service, but the entire database in the app can run, can be completely embedded. So you're going to want a back-end server that's durably storing the data and all of that sort of stuff. But the app itself, it can be anything. It can even be a JavaScript app like we were showing here. It doesn't even have to be an app server.
So users could still self-host this the back-end server, right? They would just have to figure out how to do that. It doesn't have to be Athens that does that unless Athens wants to do SaaS. So could users still kind of get the bundled version of all this and run their own server with the backplane, you're saying?
Yeah. And like I said, how you want to do that is up to you, but I'll just show kind of what we've been doing, because this has been happening to us, is that we have this K8s directory in our source code repository. And this just has some different configurations. And if people want to, they can literally take this. If they're running, Kubernetes, they can take this Kubernetes script, put it in and say, I think I don't use Kubernetes a lot. I think it's cuddle. Cuddle is the command line. Cuddle up, and the whole thing spins up, and it's running. So you might want to do something like that with Athens, where you kind of have this stuff, sitting already in containers, like on Docker Hub or somewhere else. And all someone has to do is take this script and say, if they're running Kubernetes, say, cuddle up, and that sounds like cuddle up, and I know it's not cuddle up. It's Q. I don't know. Somebody on this call, I'm sure, knows what it is.
Cube cuddle.
Cube cuddle. Thanks.
So I still don't understand how this would work to build like a fully decentralized solution. So I have my own database. It's like me, just for me. It's only hosted on my computer because I don't want it to be anywhere. I don't want anyone to be on anyone's servers except for mine. Maybe there's an Athens server, actually. It's just my local desktop app, similar to what we have now. Then I also want to connect to a shared Athens database where I have access to it and all the contributors have access to it, all the employees of Athens have access to it. Maybe there's a Flurry page that the Flurry team has access to. How would that be implemented?
So from a query standpoint, let me see if I have an example right here. Well, I don't have one right here, but we'll do it really quick. So from a query standpoint, you can have multiple sources. So what we can do is we can actually start pointing to different databases. So we're going to call, my work database or ledger, and this could have a URL, http colon, flurry.ee Athens, I don't know, whatever it may be. In your query clauses, if you're trying to return like a consolidated view of notes, for example, you can do bindings directly with different data sources. So when we're querying this database, the primary database is whatever database that we created up here, but we can actually specify different ones. And then you can prefix statements in your queries and say, okay, combine these entities, but bind, subject ID with my work subject ID. And then in this case, we'd be talking about the identical entity, but maybe they're both storing different data. So my work one stores block coworkers and my local one doesn't. So that would be a way of binding those directly. If you want to use IRIs, and we didn't actually show using, IRIs to uniquely identify things, then you're really golden, because every sort of entity, no matter where it exists on the internet, ends up having a unique identifier, and you can always use that as a binding, as opposed to using something like user email, bplats@gmail.com, is trying to uniquely identify me, for example. You could use IRIs to uniquely identify things. So that would be another way. So if you're trying to consolidate query results, that would be the way you would do it. You're starting to have statements in your queries that are binding to different data sources. And I don't know if
you can already do that with DataScript and Dayton. Right? So where's the server hosted? I mean, you can do it with DataScript and all that for sure. You can have multiple connections. You can query multiple connections at the same time. A database is just an argument. So I get that you can query multiple databases. Where are the databases hosted in the case where I have my personal Athens database? And this I have my personal database on my computer, nowhere else, and then there's a shared Athens database between all the collaborators of Athens. Where is Flurry hosted in this case?
You would have one in both locations. You'd have one in the central location and one running locally. And this is how you would combine them.
Who manages the authorization and permissions for the Athens database? Shared Athens database?
You can actually set up smart functions. So only the users can manage their own authorizations if you want. You could be an entity or a service as Athens that helps people manage their identity. There's a concept of authority in Flurry where you can actually delegate other individuals to be able to perform operations on your behalf. We call that the authority model. Sometimes people, front end an authentication service in front of Flurry, OAuth, or Keycloak, for example, is another common one that a lot of our government work uses. So I think there's a lot of options. I think the question is, what do you want and how do you want it to work? And I could probably, if I'm not answering it well enough at this point, it's maybe because I don't understand where I'm missing the mark there.
Is there someone who creates the first Flurry database that has like permissions, and they can say like these people have access to my database?
Yeah, and in fact, that's what we did here. So when we created this new ledger, the very first thing we did was transacted schema, right? And then at the point you have a schema, you can start layering in smart functions if you want to control permissions. And again, that's only if you want to. You don't have to use those. Then people have a cryptographic identity. If you really want to decentralize it, you would end up likely using private keys. And this private key can prove who I'm at any instance. They've never seen my private key. They've never seen my public key. All I need to do is tell them my identity. And when I sign with this private key, every Flurry instance can figure out who they are and if they have any sort of standing or permission on that server. So the queries end up getting cryptographically signed to do that. Now with Department of Education, we're also doing a lot of work with VC DIDs. And I mean, this to me is the future. This is where I think everyone should be looking. Wow, that was the wrong page. But here at the W3C, this allows people to individually manage self-sovereign identity. And you can start setting up permissions, which is really cool without even knowing the user up front. So you could say, this user can transact this or this user can see this if they're a US citizen, they currently work for Microsoft, and they had at least a 4.0 GPA from an Ivy League school. And different credential providers that you end up trusting, and it can sort of be down a chain, will assert these things. And as long as up the chain you believe these entities, that would be an example where I wouldn't even need to know about you ahead of time to give you permissions to do certain things. And that's super cool. And that's really where I think the world is going to be in a few years. Ironically, places like Department of Education are sort of trailing the ground there. But this allows people to manage their own identities however they want, and then you get out of that business entirely. You just set up what we would call trust chains. But that could be another thing to think about, depending on what you're trying to accomplish.
So Brian, just going back to Jeff's question and how this could run in the context of Athens, I think, Jeff, correct me if I'm wrong, but what it sounds like is if you had just a self-hosted graph, right? It's individually owned. You set it up, you set up the permissions. It'd be equivalent to just running like a local private graph. And then you also had a shared graph that was, at first say centralized. And it's kind of how we're trying to do with Athens right now with real-time collaboration. It's a central server, everyone's writing to it, and the app server handles the reads and writes. Or alternatively, you could, in that same scenario, that shared graph, decentralize it and set up multiple servers that run on RAF consensus. And then, in either of those modes, you could federate queries, as you were showing here with Sparkle, and you could just kind of put the database as a prefix and still keep your individual graph privately owned, not shared with anyone except through smart functions. And then just federate queries to these either centralized servers or decentralized servers. So you kind of have the option to run it in these multiple modes. Does that sound about right, both for Jeff and Brian?
I'd say it's right for me. And then, the thing, and maybe I wasn't understanding this part of your question, Jeff. If you're going to connect two different servers together, you need to know like the IP address or where those servers are. So there's no like this magic way that, it knows where Flurry work is. like I'm going to have an IP address or something like that that's going to be pointing at that server. I'm also going to say, hey, I'm running one on a local host, and that would be enough for me to start actually combining query results, if you even want to combine query results. So that's I guess sort of a product decision. The product might even be better if you didn't try to combine query results. You just allowed people to navigate between these things, via some sort of UI. But whatever, either of those work. And yeah, any of those server addresses that you're pointing to could actually be decentralized if they wanted to. So and Athens could run one if they want. I would say we have a good number of people who are actually hosting all their customer data. They're not even running it locally. But because they can wrap the smart functions and the cryptographic proofs around it, anyone who contributes data can prove that Athens never manipulated my data because all the cryptographic proofs are there. The smart functions prevent anyone from seeing it, and I control my own data even though it's physically on your servers. So that may also be enough. Those are a few different thoughts.
That's a good summary, Mate. And so how would real-time collaboration work in this model? Say we're federated to like two different databases, my own and then like Athens work.
So just maybe give me a quick use case. What's the collaboration doing?
So I'm taking notes right now on Flurry on my personal database. I'm learning about the RAF protocol, and then I meet with a few of the contributors here working on the back end, and we are sharing each other's notes on the back end on distributed systems, on production architectures. I want to link to their notes for my database. I want to link to some of my notes in collaborative database.
Yeah. I mean, that would, the answer is I don't know. There's probably a lot of ways. That would be a good use case of using IRIs, which, I didn't actually show here, but we can, I could try and show you here really quick as long as I don't fat finger things. But instead of using, these internal identifiers like we have here, there's no real good way, guaranteed way of linking across entities because my internal identifiers might be differently. So this is where JSON LD comes in and, actually linking data in the web the same way that web pages link data, across the web, or web pages link web pages for humans. Link data links data for machines. And so I would probably, if you're going to connect, go to this format here where you're using an add ID and you start using IRIs. And the IRIs, you can make whatever IRIs you want, doesn't really matter. There's a lot of things already identified on the internet as well that you can use those IRIs for, but it creates a surefire way of linking objects, the things you're talking about, without having to coordinate some sort of other method. So I would think about building something like that into the app that when you're creating notes, it's creating an IRI. That IRI could be hosted anywhere, so you don't necessarily have to tie that IRI to like an IP address or anything like that, but you do have a guaranteed uniqueness around that IRI that different things can now talk about the same thing and be guaranteed that they will resolve to the same entity.
So basically, you could, for each block, give it an IRI, and then each block is globally accessible, still defended by the smart functions. And so if Jeff and I were both had our own private graphs and I wanted to like embed his block into my graph, I could do that easily with an IRI, and I could see his block embedded in my graph. That wouldn't be necessarily real-time collaboration because you still have to like issue the query, so there's this like the response time, but that way you could embed other people's blocks into your own graph and vice versa. And I think, Jeff, on the real-time collaboration, like if you wanted to do that, like the best bet would still be having a centralized server and, for the real-time, if you need the real-time collaboration and those speeds, you would have a centralized server. But then that could act as a node where like, okay, for my individual graph, I can now just embed the blocks from that real-time server into my own graph, which that's not a real-time thing. But I may not need that, right? You don't always need real time. Sometimes you just need to be able to access information from other places. Does that make sense?
That makes sense. How slow would that be if it wasn't real time?
I mean, it depends on the query. Simple queries typically respond in about a millisecond. So, really complicated ones take longer. If you're using smart functions to protect data, that's going to add some additional latency. So all these things, are factors to think about. If you want to run the Flurry library directly, you have the ability of registering listener functions directly on those data events. And then that is how I would trigger real-time, updates typically. And in fact, I don't have it up here anymore. I think I closed it. But when you just saw the React app that I had up and you saw it updating in real time, all that's happening there is it's running the Flurry library where you can register a listener function. And basically you're saying, call my function every time there's new data. And your function will get called and it can do anything. It can re-render a front-end UI. It can send an email. It can, do anything you want. So that would be a way of listening to data events, even across servers. If that's something you wanted to do, you don't have to. You could, issue a query every 30 seconds if you wanted to. I don't know. It's sort of up to you.
But just add a question here. But when you just showed us with the React app, it did that already. There was like something like a socket listening to the database, and when you issued a transaction, it is already updated. So there was like some sort of mechanism that you did, is that you already implemented a listen function in that case?
Yeah, I did. So right here, right in the Flurry API, you see is FlurryDB listen, and you just give it the connection, what you want to listen to, and you give it any sort of, key, so you can close the listener if you want. And now, every time there's an event, we actually put two variables in here. Every time there's an event, my function's going to get called. I can do anything I want. Send emails, I can re-render things. So in the JavaScript version that we were seeing, that's all that's done here is basically we're registering event listeners, and there's a WebSocket connection. So you're right. So basically when I created this connection right here, whether it's in JavaScript or Clojure, when I create this connection, what's actually created is a WebSocket connection in the backend. And that WebSocket connection is automatically getting fed data events in real time, and they're permissioned. So if a data event happened that I can't see the data for, I would never get it. It wouldn't trigger my listener. So it's only going to push through data events that I have permission for based on my smart functions. And again, you can write your own code to enforce your own security if you want. You don't have to use smart functions to do that. You can run this like any other database. But if you wanted to, then those smart functions will only allow the data changes through. And then based on the data change, you can do, whatever you want. That might be a way.
And that's really, really cool. So let's say so how does this work in the blockchain example where there's just like one gigantic Bitcoin blockchain that is globally accessible? So let's say that there are millions of people that want to read King James Bible IV, and they want to reference it, and they want to collaborate on it. Like how would that work in kind of like this like Bitcoin example? There's just one global blockchain. We all want to reference it. And get permission to listen to something.
Yeah, I don't know if I fully understand the question. So for one, the easiest way, if multiple parties are not collaborating, to reference an entity will be from some unique identifier. We build in the notion that you can use IRIs. That's a great way of doing things. It doesn't have to be. You could use things like email address if you were talking about users. So you can have multiple unique identifiers. So I guess that would be the first thing, is deciding how you're going to uniquely identify something so that it can be collaborated around. And, Flurry's not going to solve that for you. It's going to allow you to use any of those identifiers real easily. But, figuring out how you're going to do that would be the first step. And then, you have the option of either creating multiple records about those items. You could even create multiple predicates if you want, or sort of attributes, I guess, in your language, where different companies are even adding different attributes that maybe only they can see to a specific item. And in that way, they're collaborating around it.
Yeah, sorry, it wasn't a clear question, but I'm still trying to understand it myself. But I feel like there's a use case where there's like we want one canonical knowledge graph. And we want it to be, like, we don't want it to be centralized, but we still want anyone to be able to.
Yeah, so the complication with knowledge graphs usually, attempts to get resolved with ontologies. And we didn't even get into ontologies here. And the reason we need ontologies is we need to start to create effectively a class hierarchy. And that is because the only way of really resolving different things talking about the same thing, because they're all going to talk about it a little bit differently, is you need to abstract a little bit. So we didn't show it here, but you can create different class types. Classes can have subclasses, and it can allow people, even if they're talking about, I'm talking about a bicycle, you're talking about a car, but it could allow a third party to come in and say, I want to find all vehicles. And we automatically know that a bike and a car are vehicles. And so they both show up in that query. And I may be manufacturing a specific type of bike, a tricycle, for example, but someone wants to find, well, I guess that's not a bicycle. Bad example, but a tricycle is also a vehicle. Like, so these sort of cascading class hierarchies are typically how people end up resolving that problem, because it's a hard problem. I mean, it's not, it's less a technology problem than it is probably a ontology and sort of taxonomy problem.
So
I didn't mean like, how do we create like a shared ontology or like a shared knowledge graph, like in the semantic sense? I meant like, could we have a global Flurry instance that anyone can read and write to, but it's still decentralized in a way that Bitcoin is?
Yeah, so you might have just helped me, I think, clarify something. So you can run any number of Flurry ledger servers, but Flurry ledger servers are only connected together if you explicitly have them participating in validating the same ledgers. The combining ledger data, combining multiple instances, doesn't happen at the ledger server at all. It happens at the query side. So what the query side does is it allows you to start connecting to different ledgers or instances and bringing those together and doing joins inside of the query. So that those joins aren't really done in the ledger side at all. Now, multiple parties can participate in the same ledgers if they want, but they're all going to get visibility on the back end to the data, because there's no way for them to validate the data if they can't see it. I can't validate a cryptographic signature if I can't see the JSON that was signed. And the JSON that was signed has data in it, and I have to be able to see it. If I can't see it, I can't validate the identity. So those backplane ledger servers are going to have really full visibility into all the transactions coming through. And you can say, hey, these 3 ledger servers, that are participating in the network are only responsible for this one ledger. Or maybe it's Athens running it and they're responsible for 1,000 ledgers. That's fine. They're all just ledgers running in this thing, and they're all validating and working together to have redundancy and all those aspects. But if me as a user need to connect to completely independent, like organization Athens servers, for example, that's happening at the query level. I hope that helps.
Yeah, but my question is, like, could everyone that's like using Athens connect to? I get the queries and joins are done at the application level, but like, could there be a single Flurry instance that everyone could connect to?
So
yeah, and you could set up smart functions so that you can allow other people to connect to it too, and even issue GraphQL or SQL queries, and they'll only ever see the data they can see, and they can control who has access to their data. Absolutely. I mean, that would be a cool way of running Athens, I think, which is, hey, we're Athens, we're running it. We're running it using this technology that is allowing you to control your permissions and how you share your notes and your data. We're keeping it secure, and we can actually even have proofs that if we ever wanted to expose them, that can prove that we never manipulated data that, Jeff submitted really came from Jeff. There's no way we could ever changed it. And then if you really want to run one inside your own company, you can, it's up to you, but we provide an immense amount of protection if you don't. I mean, I would think that would be a pretty good message, but.
So just to maybe clarify a use case, like say that Athens wanted to run an Athens network, and this is like the global Athens network that everyone who, if they want to participate in the Athens network as a global graph, would be sharing the same ledger, right? But maybe with the query, they only have access to certain parts of it, or just to all parts of it. But that one ledger, that global Athens ledger, would be distributed across all the participants. And at the same time, me as an individual Athens user could still have my own individual graph, and I can combine my queries with the query server with the global Athens ledger. And those are two different ledgers. They can be combined if I wanted to, but Athens could have just its own global ledger that allows any participants to join and uses the RAF consensus, right? So you could do both. Or if someone wanted to set up a different global graph, right, aside from Athens, you could still do that with the same platform. So like if a different organization that was creating some sort of like maybe a research coalition was setting up their own global knowledge ledger, same exact thing as Athens doing its own. So would that work, right? Like maybe I'm getting
so you could say Athens is running the main sort of back end, and people have this option of running their own if they want. You have two choices at that point. One is do I run everyone on the same ledger? That actually work really well. Everyone would have visibility into the ledger, except they would only see data they have permission to. So it doesn't matter how they try and query it, they're only ever going to get results of their sort of virtual database inside of your larger ledger. If you wanted to, you could actually set up an individual ledger for every user, but you're still managing the backplane. That's a fine thing to do too. That's going to make your queries a little bit more complicated because now you're going to have to get into the syntax where you're pointing at different ledgers, as opposed to just, giving it one ledger that it's doing these queries, but it's filtering out data. But absolutely, you can do it. Or you can combine multiple ledgers running on completely different servers. That's going to complicate it a little bit more because now you got to point at multiple sort of servers. You got WebSockets open with more than one server now that are getting event updates. But certainly, if that's, an important feature, that is also possible.
I just have a question regarding if you want to have all people on one ledger versus each one have their own ledger. Does it has any like scaling implementation? Like, is there a limit? Or if like I have like X number of user connecting to this ledger, then at this point I would need like to split up or like use multiple server like to balance the load. Is there
good question. So on the query side, you really have no limitations. So because you can spin up query servers. But on the transaction side, you will have limitations. So that's something to consider. Is if everyone is going to be making very, very frequent updates and you have a lot of users, you might want to run it across multiple ledgers, and that's gonna one nice thing about the Flurry and the RAF consensus is, as well that we do is that we'll actually load balance your ledgers across servers. So for example, like Datomic, at least it used to be like this. They have one ledger server and that's it. Doesn't matter how many databases you have, and you can have like one redundant one. So after a few seconds, if your primary fails, it'll go to your second. Flurry is very different. You have three, they're all actively running. They all have a hot copy. Anyone can go down at any time. It will stay running. But importantly, it'll actually distribute all the ledgers running on that server to all the different servers. So server A gets, 15 ledgers, server B gets 15 ledgers, server C gets 15 ledgers. And if server C goes down, the 15 ledgers that it has gets redistributed to the 2 servers that are left. And then if server C comes back, it rebalances again. So it's always balancing the ledger load. Now, with everything in a single ledger, no more than 1 server can transact it at a given time. So you are going to create a bottleneck by having it on the same server. And part of that's just thinking about, how much transactional volume you have and you expect, and, thinking through some of those.
What are you saying? You can't have the same ledger on different server?
There's copies of the same ledger on different server, but one ledger is only responsible for processing updates at a given time.
Because you want to confirm that transaction being consistent, right?
That's right. Strong ACID consistency.
But if you are creating virtual ledger, does that resolve it? Because if like 2 users creating like private transaction, it does not matter that one. It makes sense in theory that you don't necessarily want to have 1 server that have to listen to them because they are like contributing to private one. But then again, you would lose the sense of why you need 1 ledger.
Yeah. So on the query side, it doesn't matter. But on the ledger side, it still will. I mean, maybe in the future we try to, build in some sort of locking mechanism that can even distribute load for a single ledger across multiples. We actually have a notion of sharding already in the schema of Flurry, with the idea that based on IRIs, you can set up namespaces and break them into shards, but it's not in the product yet.
Mm-hmm. Yeah, makes sense. So it would be that each copy of the ledger would be responsible for a specific number of ROI. So
that's right.
So that's if 2 are contributing to different ROI, it does not matter that they have to be handled with the same ledger, but eventually they will be merged or like synced across different ledger.
That's right.
All ledger, yeah.
And then the restriction is that within a single transaction, you really want all the things getting transacted to be in the same shard. And as long as they're in the same shard, that's great. If they cross shards, then, it gets really complicated really quickly. But again, this isn't in Flurry yet. You'll actually see it in our schema. We have the foundation and everything there to do it, but it's not live at this point.
This is like work in progress, yeah.
Work in progress, that's right.
All right, it's been an hour and 40 minutes. I don't have any other questions at this time. People can hit back here on the floor. Let me know where we are right now.
Yeah. Okay. And I need to run too. I just want to say, hey, thanks for everyone. There's still got a pretty big audience here, even after that amount of time. If you have any feedback or anything like that, let me know. And, I don't know that Flurry's right for you or not. And, if it is, we'd love to help. If it's not, that is 100% fine too. I'm not trying to convince anyone to pick something that doesn't map what you're trying to do. But any questions, feedback, if you want to dive into other topics, more later, we can set something like that up. But really, thanks so much for your time today.
Thank you, Brian.
Thanks, Brian.
Take care, everyone.
Thank you.
Thanks, everyone.
Thank you.
Take care.
Thank you.